Welcome back. In this video, we're going to talk about our first operation on vectors in R2, which is going to be called the 2 norm. Recall, all vectors in R2 have a magnitude and direction. We're going to look at how to measure magnitude using something called the 2 norm. It's a very, very special measurement with regards to magnitude. So let's talk about a vector x which connects points P1 and P2. And we'll assume that we have the same notation we used in a previous video, that P1 is given by coordinates x1, y1, and P2 is given by coordinates x2, y2. You could tell these are points because we use parentheses and not vectors. We noticed that the vector would be written as 2 components. The first component would be the difference in the coordinates in the first place, and the second component would be the difference of the second coordinates. And we could graph this thing on the coordinate axis using our intuition. Recall that when we graphed the first point P1, we said that that point P1 was x1 units along the first coordinate, y1 around the second coordinate, and then here you would have this x2 units along this, y2 units along that. And then we said this is the vector x, and because we were specifically told that the initial point of the vector was P1, we knew this wasn't necessarily the origin. So the direction here, we could call this direction A, comma B. For every A units you go over, you go B units up. And this should look something like a slope, because that's exactly what it is. The slope is B over A. So here we go A units over, and we go B units up. So the direction is A over B up, A over B up. Rise over run, B over A is the slope, if this was to be a line. Directions are for vectors, slopes are for lines. Now the question that we want to ask ourselves is, well, how would we find the magnitude, the length of this vector? Well, do you recognize this at all? If I wanted to find the length of the segment connecting a right triangle, you know, a theorem by a friend of yours named Pythagoras that you could use? Well, the Pythagorean theorem says that if you have A, B, and C are the lengths of the sides of a right triangle, and in particular C is the length of the hypotenuse. So here's C, here's A and B. Then we have an algebraic relationship between these lengths. A squared plus b squared equals c squared. So in particular, when we're looking at the length of this vector, we could say that the length of the hypotenuse is a squared plus b squared. But we see from that previous screen, a was given by the difference between the first coordinates of our vectors, of our points, and b was given by the difference between the second coordinates. So this is going to be x1 minus x2 minus x1 squared plus y2 minus y1 squared, which implies that c would be the square root of these. So this is going to be x2 minus x1 squared plus y2 minus y1 squared. This is what we're going to call the magnitude of our vector, and we're going to write it in a special way. That's called the 2 norm of the vector x. And notice this is the two norm of the vector x is the square root of the squares, the sum of the squares of the components. Right? This right here is going to be called the distance between points P1 and P2, because here P2 and P1 were the allowed us to give the coordinates x sub 1, y sub 1, x sub 2, y sub 2. This here is going to be called the 2 norm of the vector x. You might see this called magnitude. I don't like to call it magnitude. 2 norms are going to show up for the rest of your mathematical career. This is a very, very famous thing in mathematics. Magnitudes, literally the only time we talk about magnitudes generally is introductory calculus. They're the same thing. You can call it the 2 norm of the vector x, or you can call it the magnitude of the vector x, which is the sum of the squares of the components of the vector square rooted. Okay, let's go ahead and do an example with this, which goes back to the examples we did in previous videos. Find the magnitude of vector x, or the 2 norm of vector x, where x goes from q to p, and q was 1, 1, p was 5, 4. Okay? Well, we recall if x goes from q to p, then x would be 5 minus 1, 4 minus 1, in brackets, so this would be 4, 3, which implies when I take the 2 norm of this thing, when I go to take the magnitude, I'm going to go ahead and do something a little crazy. I'm going to first square it, because square roots give me a headache. And we know that the 2 norm squared would be the sum of the square of these things. Okay, because remember, from the last part, the 2 norm is the square root, which means that if I take the 2 norm squared, I just get the sum of the squares, right? And that's exactly what I'm doing here. Okay. Well, this means that the square of the 2 norm is going to be 16 plus 9. 16 plus 9, we hope, is 25. And then this means if I want to take just the 2 norm, or the magnitude, I can take the square root of this sum, which is 5. In other words, when I look at the vector connecting these 2 points, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so here's this one. Here's this one. The length of this vector, we know this was 4, this was 3, and the length of that vector is going to be 5. So here we have the magnitude, which is 5, and the direction is 4 over 3 up. 4 over 3 up. And you can see that based on the direction here. All right. In the next video, we're going to talk about addition and subtraction of vectors, as well as something called scalar multiplication. I'll see you in the next video.